Cool. Hi, everyone. I'm going to talk about activity-based models in Visum, but these are from the perspective of those that have been implemented in Visum already. So this is not your next generation spaceship, but your current day, whatever, F-16. So we'll take this by examples, 3 types of examples. 2 different ABMs developed by various consultants. One ABM developed by us in collaboration with a major client of ours, Swissrail, that Martin talked about earlier today. So from that, these exercises, we learned a few things. So I thought it would be a good idea to put this in some slides and share this. So if you're doing some similar work, you'll have some pointers to get kind of a head start on. So, okay, activity-based models. Let's cover a basic definition. What is an activity-based model? The key elements of an activity-based model is the household and travel entity or person is represented in a disaggregate manner. So every person is an individual with individual characteristics as well as household characteristics and such. So everyone is either an individual, or you can call it an agent if you give it more detailed behavior. Then the time use and activity participation and scheduling, that is also explicitly done. For example, you could do a lot of what an activity-based model produces if you were to only take matrices, and you would be fine with that if the need of your study only requires that aggregate data. But in certain cases, it's useful to have these type of disaggregate outputs which have some sort of synthetic individual trips and so forth. So you can test this out in scenarios which require a discrete input like mass or mobility as a service or trip requests with Uber, Lyft and these type of things. So, or bike sharing and so forth. So it kind of gives a little bit more of a easier transition platform from that as well. So that's the basics of an activity-based model. And also the second part over here, the activity participation and scheduling with constraints, that is typically the most complicated part or tricky part in solving an activity-based model, because there are a lot of things over there that don't necessarily have statistical validity and so forth, or get overridden and such. And most activity-based model calculators differ in that mainly is the scheduling as well as like explicit activity participation, which could be either joint household or it could be an individual only. So these are a couple of key things in which an activity-based model is different from the traditional models that are 4-step and tour-based models that we use. All right. The 2 commonly used approaches for activity-based modeling nowadays, one is the utility maximizing approach, which basically connects a set of disaggregate discrete choice models together in some sort of a logical sequence to come up with an activity day pattern like Martin explained earlier today, so that you have an entire chain of activities of a person, or if there is a household interaction, then forced by probabilities of that household interaction, you can have joint household travel and so forth. The other philosophy, or 2 examples of this, are Philadelphia. dvrpc is an agency that uses Visum, and they're a major user. So they're using an interface with DaySim. And Southern Oregon, which is the model system is managed by Oregon DOT, and they've used CT-RAMP. And both DaySim and CT-RAMP are consultant-developed activity-based calculators, ABM calculators, and they have kind of evolved over the years with contributions from many consultants. So these are the 2 examples, and this is primarily the case that you might find in the US, is econometric style utility maximizing models. Then Another approach that is become somewhat popular is the computational process model. So what the computational process model has more of a what do you call it, decision chain mimicking and heuristics to actually calculate a day pattern. And the merit of this particular approach is being stated as that there are certain elasticities and so forth which are assumed in the utility maximizing approach, which are not correct or don't necessarily represent a valid relationship. So with this kind of a heuristics or rule-based calculation, you avoid this idea of having some sort of a strange outlying kind of case that will probably not happen. So that constraint is more explicitly applied in the computational process model. Another thing between these is that with the utility maximizing model, even though we apply econometric models at each stage of the ABM calculation, the sequence has to be locked in that the time use has to be continuous, and also there have to be, if you're modeling joint travel or other things, there might be a necessity for rule-based overriding of certain decision-making blocks. So you might get an output for the Monte Carlo simulation, let's say using a probability distribution to be something, but at that point that might not be a viable solution. So then a certain rule will override that type of calculation typically. So there's still kind of a post-processing or back and forth with the scheduling model again to keep it kind of streamlined. The computational process model tends to avoid this kind of a thing because they don't boast about too much in terms of econometric calculation and such. So they don't suffer from, as a consequence, having to make it seem like there is a lot more significance to the econometrics than there really is. So a couple of examples of these are Albatross and Tasha. So Albatross is implemented in Europe. It's kind of from the Netherlands, and Tasha is implemented in Toronto. So Greater Toronto has a variant of this Tasha computational process model. Typically, all of these models are open source or they're freely available. Your investment in time is the cost of the model to learn how it works. So that's the cost that you pay for it, is that open source is not necessarily always free. You could be paying in a different way. So it depends on which one you like doing. Okay, so for that purpose, at PTV, we didn't go with an approach like Martin mentioned earlier in the day to just get done with implementing some activity-based model and saying, okay, we have an activity-based model, because the approaches differ and each place has its preferences and so forth. So we went in the direction of providing kind of a framework that holds together the type of data or optimizes the data structures that need to be held in an activity-based model output, as well as insights on computations and so forth. So the general process of that general platform look like this. We have an external open source solutions for, let's say, generating a synthetic population, which then we provide the appropriate tables for households and persons and locations to properly hold and compress so that they don't take gigabytes and gigabytes of memory to store a large model size. So basically the idea is to minimize the redundancy in data storage. And then again, link it with, once you have the population and activity data, then you could use an ABM developed by a user that at some point could be also changed into PTV's ABM, but that's not going to be for a little bit of time. Then the next step, you get the output as unassigned trips and tours. This is the main output of the activity-based model. So the output from that is essentially like what you get from a travel survey. So if you look at a household travel survey and output of an activity-based model, these two things are comparable. It's just that the household travel survey has a sample size and the ABM will have the whole population. So that's the main difference. But otherwise, looking at the ABM results after the calculation is done is sometimes more intuitive and easier to query because you don't have to store everything in a matrix format and so forth. Then we also have features for disaggregation of assigned paths. So we do have assignment paths in Visum. Using the same sort of Monte Carlo method to each individual that we store up in the data, we can link a path used with the same sort of Monte Carlo allocation logic. So that's basically what refers to this disaggregation of assigned path sets. And then sending that data back into Visum. And what that allows us to do is to do these large integrated flow bundles where you can see the entire trip chain and so forth, which Martin did show a demo of earlier. So having this kind of organized data structure allows you to compress a huge ABM output into a much smaller file size. And then it also allows you to run a lot of these post-calculation procedures, which are usually the main thing out of a model. So it makes the model, the idea is to try to make these activity-based models less cumbersome for users and more easy to use, but still allow flexibility, which is sometimes a difficult balance. All right, so phase 2, the idea eventually is to plug in all of the Python scripting with Visum. So those two boxes over there, between pop and act and unassigned trips and tours, those instead of scripts or your custom ABM, DSM, CTRAMP, whatever you might have, we would eventually like to have just Visum do the whole thing. But not without, first we need to learn the various stages in ABM calculations before we actually go ahead and implement something that is usable by any regular user. So, okay, interfaces with third-party ABMs. So these third-party ABMs, like I said, could be DSIM, CTRAMP. There's probably Transim sitting somewhere, or other activity-based models, what have you. So the general idea is to calculate the activity-based model externally, as in, let's say it has an executable file of its own. You prepare what you need to prepare in Visum, which is normally network level of service, skimming data, and you send those travel times and costs and so forth into the ABM, and the ABM executable runs the whole thing, pushes out some data, which is your travel diary-like output, and then we load that back into Visum for display or analysis and so forth. So that's the general framework of integrating any activity-based model with Visum. Now, based on what we have in the US applications, we have one model which is being implemented more as an external COM call to Visum, and one model which has been implemented more from within Visum, that is within the procedure sequence and so forth. So I'll discuss both of these so you have an idea of the general options available to you for applying your activity-based model or interfacing your activity-based model. So first I'll talk about the dvrpc interface. Their interface is more configured like this. So you can see there's a Visum procedure sequence. So it doesn't look any different from what you're used to seeing. The only difference is that in the middle over here, you can see a mix of script calls, and then you can see a mix of internal skimming calculations. So we embedded all of this inside Visum so that when you run it, you can single step through each of these procedures. The other part is that we have separated out the iterative calculation from the initial free flow skim calculation. The reason for that was that if you just run this group 1 with the initial skims, you can actually run it and validate that your ABM actually is producing some output which looks okay before actually going into the iterative calculations, because more iterative calculations means a lot more computation time. So it kind of gives you a way of pre-validating some of your inputs into the ABM before just going with the whole thing, having a model run for 16 hours and then error. And then you have to go back and fix it and all these things. So this way you can kind of self-test it first before spending another 16 hours on another test of whether you fixed the bug or not. Okay, so this is one interface. We recommend this because we implemented it. So do it like this. In the middle over here, still you will see some Py scripts that call the assignment and skimming. Two of the modules that we found very useful in this case were the OSCS modules. I mean, it's a pretty trivial thing, but I still made a screenshot and put it over there because it seems like no one picked up the fact that you can execute like commands on command prompt with OS module or sys module. So that's why I thought it was a good idea to put it in there, because there was another case where we saw the vendor using some, or the consultant using some really wacky combination of BAT files combined with some R files, combined with some Py files and this kind of thing. And I don't know about most people, but I wouldn't find that structure convenient to use because you are just rummaging level after level and you don't really know where the error is if you do hit errors. Okay, so as far as possible, if you want to see the error log right in the procedure window over here, implement the procedure like this, and that way it's even easier to troubleshoot the model if it crashes later because you see the error right up in Visum and not something that just happened in a DOS window or command prompt window and then vaporized. So you don't want that situation because then you can't diagnose the error. And ABMs always error out. So don't live in the fantasy of universal healthcare. So don't do that. So just as an analogy, it's complicated. So interface developed to work with dvrpc. What we did over here was we still did multi-thread the assignments on multiple cores. So with Python, there is generally a disadvantage to multi-threading in that Python has a global interpreter lock. So that prevents a process from truly multi-threading. So this is a hack to that global interpreter lock where we spawn out Visum as a process. When you spawn out Visum as a process, Windows does the heavy lifting for all the scheduling of the process, and you can still use all of the cores effectively. The other benefit of this type of approach is that you don't have to open and close your master version file multiple times, because sometimes these files will have large networks, and that can have large matrices, and that can take a lot of time to save and open. So you don't want to lose computation time on just saving and opening a big file. The other approach that has been implemented is this external approach, where Visum is called externally through COM. And this is how it works. This is a Southern Oregon example. So you have a Python controller master script that controls both Visum and the ABM, ctramp ABM, which is through Java. So one master script calls Visum many times. This seems like a sequential also calculation, so there's no multi-threading between different time periods for skimming and assignment, which can be useful to save time. Also, another aspect of this that we found some issues with is that sometimes when you're calling the model or COM server from outside, you could have license conflicts. So if you have multiple license pulling from a server, then you should be careful to either isolate that machine when you run the ABM so all instances are accessible, or basically not call Visum so many times through COM. From like this one, for example, just for some of the skimming, 20 times opens Visum, closes Visum. Okay, but why? So last one was the internally calculated ABM. This was implemented in collaboration with Swissrail. They're one of our major users in Europe. So they were interested in having an in-house ABM. So we collaborated with them because there was a bunch of things to learn for us in it and for them as well. So the key things that we wanted to learn from it were computational effort in a real scale ABM, Then how do you develop and optimize data structures, which I talked about for storing large amounts of data. Identify where the flexibility needs to be maintained, what components should be moving, what components should be locked down and not necessarily open to the user easily at least. And then possibly experiment with offering an ABM. This is just possibility of testing something like this, because this cloud service environment is something that has been in discussion, but this is not a strict thing that we are testing actively as such. And what kind of output needs to be assembled? So what are the outputs that users want to see immediately, and what are the outputs that users don't want necessarily to see immediately, but they like to post-process and have a look at specific elements. So doing an ABM on your own gives you an idea about all of these things. The key thing also that it provided us was the scale of the model, because we won't be implementing a ABM that doesn't work on a real life scale. So here's our model area in this prototype that we worked on along with Swissrail. So this is the entire country of Switzerland, and we have 3.8 million households, 8.6 million individuals. So this is not a toy model. This is a real scale model of an entire country that actually has a transit system with viable service. It's not a transit system that just is there, but heavily used rail system. So
they also have national program.
Yeah, but it's a small country. So here, so 5 million jobs. You can see where the how the land use is sprinkled over Switzerland here, and then how does the land use look like when housing in green and business in orange. Okay, so what did we do with this eventually? Eventually we implemented it in this framework. So this kind of idea of this framework came from actually hands-on doing this implementation, because live and learn. So that's what we did. Here, okay, some Python, SVB has a custom population synthesizer. So they use that. We just inserted that data into the data structure in Visum, and then learned a few things about absorbing this huge population demographic data into Visum. So we added some new COM functions like set, add multiple, and get multiple. So that way, if you want to add, let's say, a few 100,000 rows, that function works more efficiently than calling each function line by line. Okay, then, in this case, actually one more different thing was that the unassigned tours and trips were not fed into a Visum assignment. These unassigned tours and trips were fed into MatSim. So MatSim is, it's kind of, if you were familiar with transims, the basis for MatSim is similar. It's a cell transmission type model, and it does large scale simulations. But an additional component, it's called a genetic algorithm, which evolves the day plans and tries to make those day plans better.
So what's the trip rate for this model? Like in Switzerland, what is the trip rate?
The trip rate?
Yeah.
There is no trip rate in here because it's an econometric estimated model. So we have a paper, I can give you a link to that paper that has more detail on the estimation side.
Because it has like 5 million jobs, but the population is like 8 million, right? So that's why I'm wondering like what might be that?
Yeah, because there are part-time workers and so forth. So that, and yeah, like there are different flexible job arrangements, right? So not entirely implausible. And then also reporting, right? Who reports themselves as a worker versus not is also sometimes ambiguous. So, okay, so with MatSim, it runs through an entire simulation, which runs both public transport or transit and traffic. This is kind of something that is also part of some work done over here they call it deep integration or things like that. But this is just interfacing with MatSim and just running the assignment through MatSim, getting back the assigned and refined plans in tours and sending them back to Visum for again post analysis. So that's the general workflow for the Swiss ABM. Then this is what you get out of the activity-based model once the results go back into Visum. So here's a individual day plan. This is a kind of like homework, leisure, home is one activity chain, and that has a sub-tour, looks like. It has work, leisure, home, or another sub-tour that links work, leisure, home. Okay, so here you can see that this is a Visum screenshot. You can see the actual tour with its different legs. And I don't know how clear this is, but here you can see the new tables added to Visum. So the person level table holds the person individual data, which then links with the activity execution over here. So you can see over here things like the departure time, and actually this is the tour data. So this is the overall tour data, and if the tour is a primary tour and the trips taken on the tour. Then from this you can also derive the activity execution. So this is the actual schedule. So when you see the start time of an activity, duration, end time, that's the table that holds it. And then in the end, you see the entire expanded trip output. So you can see over here in the expanded trip output, that looks like more or less your travel survey. So most of your travel survey, if you look at even the 4-step ones, they will look like that. You'll have a trip end on each side, departure time, demographic profile if it's there, and then finally your activity O&D purpose. So that's kind of the output that came out of this model exercise. So okay, computational challenges. You have to multiply a rather large number of matrices and arrays in this particular model calculation or any ABM calculation, and you have to do it over each individual, or basically do a Monte Carlo simulation over each individual, which can be computationally expensive because Python doesn't offer a method to do this in bulk. You can run multiple random draws, but not do multiple probability distributions all in one go in a vector. So our main person who optimizes all our calculations, Klaus, he's been working on a multi-processing kind of framework for this, hacking the same idea that if you launch something as a process, then Python doesn't block it from multi-threading because it has no control over it once it's off as a process. So he's using another Dask framework with multi-processing to try to optimize some of these calculations. So this is at the moment the ongoing challenge. So with that, I will say that this is where we are at practical application of ABMs now. And then if you want to see more webinars, go for it. And thank you. Yeah, if you have questions.
What was the total number of zones in that?
This one had about 8,000 zones.
8,000.
But in this case, I must say that like with a disaggregate activity-based calculation, the running time will scale with population, not necessarily zones always. Zones will become important if you're doing level of service like you're skimming an assignment on the zone level. That's when zones will become important in calculation time. But the ABM calculation itself is not as dependent on zonal magnitude than it is on person.
Would it take too much effort if we want to apply the same scripts to another model? Can easily do that?
Yeah, I mean, it will be some effort. That's why it's a script. Like, yeah, that's so finding an optimal design for this is difficult because there are several coefficients, and so that's why we went through the whole exercise of estimating the models, so we know which coefficients are actually producing that elasticity and which ones are probably just there but not really adding into the elasticity of the model. So, but yeah, it's not going to be a trivial task. I wouldn't say it will be trivial. there will be some time you'll need to spend on understanding the framework and so forth. I mean, it's not difficult, it's complicated. So that's.
So can you go to the flowchart for the Switzerland APM?
Did I have a flowchart?
Yeah.
This one? Okay.
So are those steps below population and activity, those are just the choice models for destination, intermediate stops and all that?
Yeah. So those are all your linked econometric, your tour frequency choice, and then destination choice, mode choice, all of those.
So are those included in Visum or external scripting?
At the moment, it's a Python prototype. It's not externally shared. It's implemented by PTV and Swiss Rail, so it doesn't have universal availability. But we implemented all this, PTV and SBB.
Not Visum scripting, but just Python external.
It's Python, yeah. It just interfaces at the right places with Visum. So I think that's it. Thank you.